Graphing exponential functions. Y equals a times b to the x minus h plus k. It's exponential growth and decay. Y equals k is the horizontal asymptote. If b is greater than 1, it's a growth function. If b is between 0 and 1, it's decay.
All right, well, welcome back, Algebra 1 students. You were looking at exponential functions in this lesson, 6.3 from Big Ideas, Algebra 1. And so just like that song that I had for us there is talking about exponential functions, we're going to be graphing these exponential functions today. We're going to see them going up for growth and coming down for decay. And so before we get into that, let's take a look at our cartoon. So we have a Garfield one today, a football. And kind of does, looks like he kind of does a thing that Lucy used to do to Charlie Brown there with Odie. And so, yeah, he says, throws the ball, coming back a football for Odie, and where'd you get that? And gets clobbered by the football team. Apparently, Odie took the football from the football team. All right, well, let's head into our exponential functions. The only vocabulary word for this in your vocabulary section is just exponential function. And what you can just say, it's a nonlinear function of this form. That's all it is. It's not linear, which means it's not a straight line. Now we're going to see the functions going up kind of like a rocket ship in some ways, or coming down like landing a plane. Definitely has a curve to it. And so we're going to see that a cannot equal 0 in this function. So you want to maybe write this down. Exponential function is a nonlinear function in the form of y equals ab to the x. Now that's one of the most simple ways to say it, like a kind of a basic way of saying that, where you have b as your base, x is the exponent, and then a would be a number you're multiplying this exponential for. So you don't always see the a number in front. Like if a number is 1, you wouldn't see it. It's just b to the x. A would need to not be 0, though. You can't have a be 0, because if a is 0, then it basically makes the whole thing 0. B also cannot be a 1. If b is a 1, then it will just always be 1 here, because anything you raise a 1 to is still 1. And b's got to be greater also than 0. It's got to be positive. So this base has to be a positive base. It could be a fraction, it could be a decimal, but it has to be positive. Now the a number, that could be a negative number. That would be fine for it to be negative in front. That definitely we will see. And we're going to see how sometimes we're going to look at these table of values. It could be going horizontally or vertically. It doesn't matter. And does it represent linear or exponential? That's really, we need to see the difference between those two, because so far we've really been focusing a lot on the linear functions, just straight lines, y equals mx plus b, where we see a slope, right, with a rise over run. A linear function is going to have a constant rate of change on both x and y, whereas an exponential function will have a constant rate on x, but then a exponential rate on the y. That's what we would want to see here. So you can see on a right there, it's got a constant rate going up by 1 on the x. It has a constant rate going up by 2 also on the y. So a constant on x, constant on y. That definitely means that it's a linear function. So this is going to, if I plot all of these points, they would make a straight line. But this one, if you look at this one, it's got a constant rate of change going up by 1 as well here. Constant rate of change on the x, but on the y it's got an exponential rate, which means you're multiplying. So if you're multiplying to get the next number every time, we're multiplying 4 by 2, 8 by 2, 16 times 2 to get the next one, that would be an exponential function then. So that function is exponential. When it's adding the same thing up on top here, it could be adding or subtracting. It's got a constant rate of either addition or subtraction for the x, but then it's got a multiplication or a division rate down here on the y. That would be exponential. When it's got addition or subtraction on x and addition or subtraction on the y, if that's the same operation basically, then you would have a linear. All right, let's take a look at our extra practice. Now this is on page 181 in your notes. Go ahead and pause the video and see if you can determine from each of these table of values, just like we saw in that last one, is this an exponential or is this a linear function? So that's what we want to see. Determine whether the table represents linear or an exponential function. Pause the video, see if you can identify which one's linear, which one's exponential. Alright, so hopefully you paused the video and you tried your best at seeing which one was linear exponential. Let's go ahead and take a look at it here. So our x's are all going up here every single time. 1 to 2, 2 to 3, 3 to 4. It's got a constant rate of +1 every time here. On this one, it goes from 8 to 4, 4 to 2, 2 to 1. So this one, you are actually kind of dividing. It's more dividing by the same number. It's like you're dividing by 2. 8 divided by 2, 4 divided by 2, 2 divided by 2 keeps giving you the next thing. You could also think of it as you could be multiplying by a half. That's another way you could think of it too, is you're timesing by 1/2 or 0.5. So it's got either a multiplication or a division rate, so this definitely is exponential on that one. Number 2, if we take a look at this one, it's going to see got a constant rate of +1 every time, 1 to 2, 2 to 3, 3 to 4, and so on. Over on this side, 3 to 7, 7 to 11, 11 to 15. You're actually adding 4. 3 plus 4 gives you 7, 7 plus 4, 11 plus 4. We're actually adding 4. So it's got a constant rate here of addition, constant rate here of addition, so that is linear. When it's addition on both sides, or it could be subtraction on both sides, that's linear. On this one, we're also going up by 1. -1 to 0, 0 to 1, 1 to 2. Same thing here, going up by 1. 12 to 9, 9 to 6, 6 to 3. This one, we're actually subtracting -3 every time. So -3 to 9, -3 to 6, -3 to 3. So since it's addition on this side, subtraction on this side, it's also linear. Okay, you have to have either multiplication or division on the y side in order for it to be exponential. And then if we look at our last one here, same idea, we're going up by 1 every time again. And then this one might be a little bit more challenging to figure out what it's doing on that first one, but you can kind of see maybe what it's doing here from 0.5 to 2, 2 to 8. Well, 2 to 8, you could be adding 6. Now, we're not adding 6, though, from 0.5 to 2. We could be multiplying by 4 here, so times by 4. 2 times 4 is 8. So when I do the same thing here, to get from 0.5, if I times it by 4, I do get 2. If I think of this as a half, half of 4 is 2. So that works. So we're timesing by 4 on this one as well. If you times this by 4, you get 0.5. So that is definitely exponential on this one. Oops, E-N-T-I-A-L. That's an I-A-L in there. All right, let's move on to the next section. Okay, the next section we're going to be evaluating 5 through 7 on 181. We're evaluating. Let's take a look at these two. You don't have to write anything down here, but let's just watch how they would do this. Evaluating, they give you a value for x. You're going to plug that in for x. So you can see they're doing that here. They're putting the 3 in for x. -2 times 5 to the 3rd power. So you do order operations. 5 to the 3rd power first, then times by -2. So it's 125 times -2 to give you a -250. That's your answer for that one. For b, you're plugging in a -2. So right here for x, you put -2. You do the exponent first. Now you could think of this as a half, and the negative exponent is going to flip that as a reciprocal. Negative, or 0.5 to a -2 is going to give you 4. So however you want to think of that, and I think 1/2 would maybe be easier to think of. And then if you flip it, taking care of the negative exponent, and then you square top and bottom, that would give you 4. So flip it to 2, then square it, then you got just 12 as an answer. So that one's a little bit more challenging with the negative exponent. Remember, negative exponent is always going to flip the base, take the reciprocal of the base. And since 0.5 can be turned into a fraction and then take the reciprocal of that, that would be 2, and now it would have been 2 squared to give you the 4. All right, so let's go on to 5 through 7. So go ahead and try these on your own. See if you can evaluate these on your own. And then play it again to see if you got these correct. So do 5 through 7 and then check your answers. Alright, so let's take a look at our answers here then for 5 through 7. So for number 5, if you put 5 right here, it's just 3 to the 5th power. 3 to the 5th power would be 243. That's just multiplying 3 times 3 times 3 times 3 5 times. And you could use a calculator to do that, or you could just keep multiplying by 3 to get your answer of 243. This one we're going to put 3 right here, so it's a 1/4 to a 3rd power. 1/4 to the 3rd. So basically you're going to give that to the top and the bottom. 1 to the 3rd power is 1. 4 to the 3rd power is 64. So 1 over 64 would be our answer for that one as a fraction. We're going to plug 4 in here, so it's going to be 3 times 4 to the 4th. So we're going to need to do 4 to the 4th power first. 4 to the 4th power is 256. So 4 times 4 times 4 times 4. You just keep multiplying 4 times. Gives you 256. 256 times 3 is 768. Now, we could do this on a calculator. Let me just show you how I would have got this on the calculator. I could have put 4 in, and here's my x to the y button. That gives me a little arrow up. That says the next number I'm going to plug in as an exponent. So 4 to the 4th power gives me the 256, and then I can just times it by 3. And so there's my 768. So you can use a calculator for some of these with the exponents. All right, let's move on to our next part here as we start to get into the actual graphing section of our lesson here. You can see the next several problems are going to be dealing with the graph. So there's a few characteristics of these graphs. First, notice the shape. The shape is a curve here. So the blue shape is just a regular one where a is greater than 0. So that's if this is positive, it's going to go up. If it was negative though, if a was a negative number, like let's say -1 or -2 or something, then it's going to flip, it's going to reflect over the x-axis. It's going to flip over the x-axis and now just go down this way. Your y-intercept, notice that y-intercept, where does it cross the y-axis? Is at the point 0a. So if you plug in 0 for x, you would end up just getting whatever a is. So the a number really is going to be your y-intercept. So that's something to realize there as well. So I like to think of these kind of like a Superman ride graph. Have you ever been to Magic Mountain? You've maybe been on that ride or seen that ride. It just zooms up and then comes back down. Or it could be like some kind of taking off, some plane just taking off, or a rocket ship taking off somehow, zooming up into the sky. Now this is for growth. Growth is going up from left to right in this case. This one, if you go from left to right, it's coming down. It's going down for decay. So we would call this one decay. So you can actually put that down there, even though we're not really dealing with those words yet, not until a future lesson. But you can put this down here right now. This would be growth, and then this one would be decay. So it's just kind of like that video at the very beginning, that song, he was talking about growth and decay. That's what he was talking about. This is decay when it comes down from left to right. It's kind of like landing a plane. And he did use this word called asymptote. An asymptote, A-S-Y-M-P-O-T-E, is this line right here. The x-axis is a horizontal asymptote. Okay, so that is going to be sometimes where it might change. It might go up or down, but most of the time, unless there's a number behind this, like plus some number, it's not going to change. So this asymptote right here, let me highlight it on this as a yellow. So this is the asymptote where it does not touch it. So if you think of the plane landing, that's why we have landing gear on planes, so the plane doesn't crash into the ground. And just kind of makes a nice, easy landing. Or if it's going to be a ride, you don't want to come down and crash into the platform. It wants to come down and make a nice, easy landing. People get on and off. So you cannot touch the ground. It definitely doesn't cross it, and it really never touches it. So asymptote is a line that basically something never touches and can never cross. So that would be the x-axis on these ones here. These are asymptotes. All right, let's move on to, you can look at this guy right here. So if we wanted to graph 4, 2 to the x, we could just do a table of values, so plug in numbers for a table of values, and then just evaluate, just like we were doing on 5 through 7, figuring out what those numbers would be for y. That's your evaluation, and each one of those is an ordered pair that we can then just plot our points of, like as you can see here, and then just connect the points as a curve. And you can see the asymptote there is the x-axis, so we're just going to keep coming down, getting closer to the x-axis this way, and it zooms up. That way we put arrows on the ends of the function. Here's another one with a negative in front. It's got a fraction inside here. So again, we do the same thing with the table of values to find out what are some of the points of this. And this one, you see it's going to flip, it's going to reflect over the x-axis, and as we put these points here, it's doing this kind of shape, still a curved shape. All right, let's take a look at 8 and 9 now on our page 81 at the bottom. It says, first of all, graph the function, compare the graph to the graph of the parent function, and describe the domain and range of f. So the first thing I'd like you to try to do, and you could just do, so let's go ahead and I'll do this one with you on number 1, and then, actually I'll do number 9, and then you can come back and do number 8. So number 9, let's take a look at this one. So if we wanted to plug these numbers in, these are the numbers we're going to plug in. I'm going to do the same thing with the same numbers. Now you could do 4, 5 numbers. You know, this one I just put 4 in here for us. I usually always try to start with 0. 0 is an easy one because if you just say 1/4 to the 0 power, anything to the 0 power is always a 1. So for this one, it's just going to end up being 2. Oops, I got my yellow there. That doesn't show it very well. Go red. So it's going to be 2 times 1. So 2 times 1 is just 2. So the y would be 2. 0, 2. We can plot that point here. 0, 2. There's a point. There's our y-intercept. So when you plug in 0, you're going to usually find your y-intercept. Where is it going to be on the y-axis? When x is 0. Then if you plug in 1, 1/4 to the first is going to be 1/4. So it's going to be 2 times 1/4. And so 2 times 1/4, you can put 2 up here, 2/4, which is just a 1/2. So 1, you're going to be at a 1/2. So we're going to be like right about there. And then for negative 1, if I put negative 1 inside here, remember the negative will flip or take the reciprocal of 1/4, and now it's going to be just 2 times 4. So when it's negative 1, 2 times 4 is 8. It's going to be negative 1, and then 1, 2, 3, 4, 5, 6, 7, 8, all the way up to here. There's a point. At positive 2, now we're coming over to the positive 2 side. If you put in 2 right here, you're going to square it up on top. 1 squared is still 1. 4 squared is 16, so it's going to be 2 times 16. And then 2 times 16 is actually going to give you a 1/8. So it keeps getting closer. So at 2, it's even lower than the 1/2. It's going to be very close there. And then you can just go ahead and do the curve. As you can come down, you can see we're going to kind of come down with our line. I'm just going to keep curving as I hit these points. I'm not going to cross the x-axis though, as you can see. I'm going to get close to the x-axis, just right above it, but I'm not going to cross it. I'm trying to not show that that's going to touch or cross. Put the arrows on each end. So there's the graphing part of it. It says compare the graph to the parent function. The parent function would just be this 1/4 x right here. So we could see what did it do, what's different. Well, this 2 stretched it. It made it stretch. So it's a vertical stretch. It's a vertical stretch by the factor of 2. So when you have a number greater than 1 here, it's going to make this graph stretch vertically. Vertical stretch by that number. The domain is all real numbers. It's going both directions. It's going to keep going this direction as it gets higher and higher. Definitely you can see it's going fast this way. So it's all real numbers on domain. In fact, all of these will always be all real numbers. And the range, where is it on the y-axis? Well, it's only above the x-axis here, only above when y equals 0. So y equals 0 on the x-axis. It's not equal to that because it's not supposed to touch the x-axis. It's just greater than 0. So y is greater than 0 is our range. All right, so go ahead and pause the video and try to do the same thing on number 8. Plug in the same numbers, 0, 1, negative 1, and 2 into here. See if you can get those y's and plot those points and at least graph it. And then you can try to describe this also information down here with domain and range and how it's different from the parent function. So go ahead and pause the video, do number 8, and then play it to check your answer. All right, so let's go ahead and take a look at what we should have here for number 8. If you plug in 0, so if we plug in 0 here, it's going to make this 2. 2 to the 0 power is 1, but it's not affected by the negative. Notice this is not in a parenthesis here. So the negative sign is never affected by the exponent when we don't have it in a parenthesis. So since it's not in the parenthesis, we're basically doing this. We're doing now negative times 1, which is just negative 1. So negative 1 for y. If you plug in 1, it's going to be negative times 2. So negative 2 right there for that one. If you plug in negative 1, so negative 1 is going to flip this upside down. If you take the reciprocal of 2, that's a 1/2. So it's a negative times a 1/2. So negative 1/2 for that one. And then for 2, if you put 2 in here, you're going to do 2 squared is 4. So it's negative times 4. So negative 4. So I plot these points, 0, negative 1. And then 1, I'm at negative 2. At negative 1, I'm going to be at a negative 1/2, which is right here. And at positive 2, 1, 2, I'm going to be at negative 4 down here. So it's doing this kind of thing. This x-axis is our asymptote still, so it's going to get closer to the x-axis but not actually touch it. So it's going to kind of come along right up here, really close, and then it's going to go down this way. Oops, there we go. Yeah, I'll put an arrow on that. So that's what your graph should look like. How is it different? Well, it's a reflection because you got the negative in front here. It's a reflection in the x-axis from just the regular 2 to the x. If it was just 2 to the x, that would be going up this way. So it's reflection. We want to use the word reflection. It's a flip. It flipped over the x-axis. Domain is still all real numbers. It's going to be that same thing on every single one. And the range here is less than or equal to 0. Now it's just below the x-axis, which means it's now less than 0. It doesn't equal 0 because it can't touch that x-axis. All right, let's go ahead and look at a couple more. First, let's take a look at this joke of the day. What's the difference between a guitar and a fish? So this is fitting to the video. The guy was playing a guitar. What's the difference between a guitar and a fish? Well, you can tune a guitar, but you can't tune a fish. Oh, brother, that's great. That's awesome. You can tune a guitar. I was tuning my guitar just yesterday. But yeah, you can't tune a fish. Tune a fish. Get it? All right. Let's go on. I know you love those jokes of the day. All right, well, let's go on to this one. Here's a bigger one here. So this one has a lot more stuff going on. It's got your base 2 in that parenthesis. It's got your a number 4. It's got our exponential, but on the exponential, it's got x minus 3. And then it's got this plus 2 behind here. So this plus 2 is going to mean our asymptote, that line that we can't cross, is actually going to move up to 2. It's not going to be at 0, which is the x-axis. So we can see how this one's going to look. So the black one would be just the normal 4 to the 2x. Well, now with this extra stuff here, it's going to be moved up. You can see it's going by 2's here, moved up. And so it's got a little bit different of a shape maybe with the x minus 3, but definitely have moved up. That's the biggest difference you probably see there on that graph. All right, let's take a look at another one. 10 and 11 now. So if you turn the page to 182, now we're going to see a couple here. 4 to the x minus 2. So it's got this minus 2 down here. That means our asymptote is going to move down 2 units. So it's not going to be the x-axis anymore. That line here is now going to move down 2 units. In fact, maybe I'll put a little yellow line here just to show us here is our asymptote right along here. That's going to be our asymptote now. So we can't cross that line. That's like the ground, if you can kind of think of it in terms of the ground. Can't cross that line. This one doesn't have that. The x-axis is still going to be the asymptote for this one. So go ahead and try number 10. See if you can graph this. Do the same thing with the same numbers, 0, 1, negative 1, 2. Evaluate those numbers. See if you can get your y numbers here as you plug that numbers in for x. Here's the numbers to plug in. evaluate, see if you can get the correct numbers for y, and then just plot those ordered pairs. And then you can see if you can describe the domain and range. Just do number 10 and then check your answer. Alright, let's see if you can have done this one correctly for number 10. If you plug in 0, you have 4 to the 0 power. So 4 to the 0 is going to be 1. So we're going to basically have 1 minus 2. I got my pen there. 1 minus 2. And you can see 1 minus 2 would be negative 1. So you got negative 0, negative 1, 0, negative 1. We're right here. That first point. If I plug in 1, now it's 4 to the first power. You're going to see 4 minus 2. And that's going to be 2. So 1, 2. So positive 1 to the right and then up 2. There's another point. Again, the x is going to be on the x-axis and then there's your y. So 1 on the x, go up 2 for the y. Negative 1. If you plug negative 1 in here, it's just going to flip that 4 to its reciprocal. It's going to be a 1/4 minus 2. Now 2 we might want to put as into fourths. So if I put a 4 on the bottom of this, 4 times 2 is 8, so it's going to be 8 over 4. 8 divided by 4 is this 2. Now we can definitely see it's 1 minus 8, which is negative 7. Negative 7 fourths right there. I'm going to change this to negative 1.75 on the decimal. So you can see how I could have done that on the calculator, just putting in 7 divided by 4, and that equals 1.75. I think that's going to be easier to graph the decimal than the fraction. So now I could see at negative 1 right here, I'm going to go down 1 and then 0.75, which is going to be closer to this asymptote down here. If I plug in 2, putting in 2 here, that's going to get 4 squared is 16. I'm going to get 16 minus 2, which is 14. That's going to be too far off my graph. I go 2, 1, 2, 3, 4, 5, 6, 7. So I need to go all the way to 14 to put a point. So 7, it's going to be like halfway about. I'm going about halfway at 7. So now I can kind of see how this is going to come up. It's going to come along my asymptote this way. And it's going to start to make the curve up now. It's starting to take off. The rocket ship is taking off. And then it really zooms up fairly fast. We'll go to right there. That's what we should be seeing. So there's our exponential function. Our domain should be all real numbers. All of these should be all real numbers. And your range is y is greater than, because it's above this asymptote, and the asymptote is at negative 2. So it's y is greater than negative 2. And that's the same number you see back here, which is our k number. We usually call that the k number right there as we look at transformations. And we'll see those more later, but just to get you an idea, that we usually call k. Okay, do the same thing on number 11. Try that one. Plug in. I put 5 numbers on this one though, so try plotting those 5 points and then check your answer once you finish that one. Number 11. Alright, so let's check and see how we do here. If I put in negative 1, I chose to put negative 1 first because negative 1 plus 0, well, plus 1 would give us 0 here. We're going to see that's going to be to the 0 power. So we're going to basically see 4 times 1 on that one, because 1/2 to the 0 power, when I plug in negative 1 here, negative 1 plus 1 makes 0. Anything to the 0 power is always 1. That's something you got to remember. It's often forgotten, but you need to remember anything to a 0 power is always 1. 4 times 1 would be 4. So there's our first point, negative 1, and we can go up 4. We're right there. If I plug in 0, I'm going to just see it's 1. So now it's going to be 4 times 1/2. So at 0, it's 4 times 1/2. 1/2 of 4 is 2. So at 0, we get 2. 0, 2, we're right here. With 1, 1 plus 1 is 2, so we're squaring it. So it's going to be 4 times 1 squared is 1, and 2 squared is 4. So 4 times 1/4. So if you put 4 over 4, that is 1. So 1, 1 is just right here. If I plug in 2, that's going to be down to the 3rd power. So we're going to see now 4 times. So if this is going to be 1 to the 3rd, it's going to still be 1 on top. 2 to the 3rd is 8. And so now if I put 4 up on top here, 1 times 4 is 4/8. 4/8 is a 1/2. So at 2, we're now halfway. -2, if I put in a -2 here, now I'm going to have a -1, which means I'm going to take the reciprocal of 1/2 and then square it. Reciprocal of 1/2 is 2, so basically it's going to be 4 times 2 squared, and 2 squared is, wait a second, hold on a second. Nope, that's not it. No, that wasn't squaring it. I got confused, sorry. -2. -2 goes in here. -2 plus 1. That's -1. Sorry, so it's just going to be 4 times 2. 4 times 2 to the first power, which is 8. So at -2, we're at 8. 1, 2, 3, 4, 5, 6, 7, 8. We're at the very top here. If I put in -3, that's what would have given me the 16, the 2 squared. Okay, so now we have all our points. We can see the direction that it's coming down. It's definitely what we would call a decay. It's coming down from left to right, and it's going to be getting closer to this x-axis. Notice there's like +0. There's nothing that doesn't have a k on this one. So your asymptote is still going to be the x-axis here. So it's like it's coming along here. Maybe do it this direction, going up, and just keep doing a curve. It goes in a curve fashion. There you go. Put an arrow on that side, put an arrow on this side. That's what you should see for your graph. And then our domain's still all real numbers because it's going everywhere. Where's the graph on the x-axis? The graph is everywhere to the left, everywhere to the right. It's going to keep going this direction. It's going to keep going that direction. And then it's also greater than 0. So range is greater than 0. Y is greater than 0. So just always remember, where is the graph on the x-axis for domain? Where is the graph on the y-axis for the range? That's what you need to figure out for range and domain when they ask you. All right, let's move on to our next one. Number 12 and 13 says write an exponential function. So now it gives us a table of values. We want to write the function from that table. It also gives us the graph on 13. So to write an exponential function, again, from the table, we were looking at this earlier. See how it's just going up by 1s on the x, but this one, what are we multiplying by? That's what we want to figure out. We know we're going up by 1 here, so +1. This one now is going up by timesing by 6. 3 times 6 is 18. If you multiply 18 times 6, you're going to get a 108, and so on. So we keep multiplying by 6. So that 6 right there is like your base number. So you can see it's going to be f of x. You're going to call it f of x just like it's called here. And it's going to be 3 times 6 to the x power. So the number that you're multiplying by every time on the x is your base for the x. And then as long as this number right here, you have 0, 3. So that's an important number. This is your a number right here. So the 0, 3, that number is your a. And then this number right here, the 6, that is the b number. So we want to put it in. Remember, our function is like y, or f of x, equals a, b to the x power. Okay, so on this one, we would want to see, okay, same idea. What are we kind of multiplying by to get to the next one? We can see the difference on this one is it's kind of doing this reflection. So it's normally coming this way. Now it's reflected over, so it definitely should have a negative in front. So we could start off with an f of x again, but it's definitely going to have a negative in front of this function, a negative a. And what would our a be? Okay, well, there's 0, negative 0.5. So you can see negative 0.5 or negative, that could be also negative 1/2. So a there could equal also a negative 1/2. So a 0.5 is also a 1/2. There's your a number that's going to be in front. We just now need to figure out what's the b number going to be. So what are we multiplying by every time? Now it might be easier to kind of see this here. Now you need to recognize that it is going by 1s. But notice that this is 0.5 right here. So it's going to be from 2 to a negative 4. It's going by 0.5 on the x. So notice everything here is 0.5. It's the next number that we see from 0 is 0.5, then 1, and then 1.5. So because of that, we really have to kind of double what we're talking about, or we need to look at from this point really here, from that point to this point here. From -1 to 4, we're multiplying by 4. So it should be 1/4. So the 4 is the number, but it's a 1/4 on this one because we're going in this direction. It's a decay. It's got to be less than 1, a 1/4. I know that one was probably a hard one to see and understand. So let's recap real quick. Your A number right here at 0 is this number here. Your B number, what are we multiplying by every time? And you might want to write everything out in this fashion, more of in a table of values. You could do that to kind of see just the ordered pairs instead of seeing the graph here. And then you can kind of see what are we multiplying by every time as we go up. And it always has to go up by 1. Notice this is going by 1, so you can use 6. If it was going up by 0.5, then we're doing something a little bit different. It's going to be kind of half of that. So that's why it's a 1/4 here on this one and not just 4. Or it's not also just 2. It almost looks like 1 to 2 and then 2 to 4. It almost looks like you're multiplying by 2, but you got to realize it's not going up by 1s on the x. That's why. All right, let's take a look at our last one here, number 14. So number 14, it says to graph the function of f of x, then graph the function g of x. Okay, how are the y-intercept, domain, and range affected by the translation? So what I'd like you to try to do first, go ahead and pause the video and graph these two functions on the same coordinate plane. I drew it the way you're supposed to draw it here. So draw your x-axis and your y-axis like this. And then graph these two functions. You might want to use different colors to represent them. That's what I'll do. Just graph those two functions, see if you can get the right graphs. And then play it to check your answers. All right, let's take a look at our answer here for 14. So I'm going to start with just the f of x function, 2 to the x. We'll do that one in red. So I start with 0. 2 to the 0 power would be 1. It's going to go right through 1 right there. 2 to the first power. So when x is 1, 2 to the first is going to be 2. And then if I keep going, 2 squared is 4. So it's going to go up to 4. And then 2 to the third power would be 8. So when I'm at 3, I'm going to 1, 2, 3, 4, 5, 6, 7, 8. So it's doing this kind of thing. When I go to -1, I'm going to be at a half. And then it's going to keep getting lower and lower here. As I can see, -2 will be at a fourth and so on. So it's going to do that kind of thing. So it'll come along like this. Alright, so that's our f of x function. I'll label it over here. Here's f of x. The g of x I'll do in blue. So it's almost the same thing. The only difference is it says +3. That means that this x-axis asymptote right here has moved up 1, 2, 3 units, and now we're here. So basically it has all the same characteristics. Everything just moves up. All of these points are just going to move up 3 points. So I move the y-axis up 3, 1, 2, 3. It's now going to be there. This one's going to move up 3 points. It's now here, and a half. This point here will go up 1, 2, 3. And this one will go up 1, 2, 3. I'm not going to worry about that one. And I notice that the asymptote here has got to be right here on 3. So I can't touch this line right here. I'm going to come across it like this and go up. And that's my g of x function. So it's almost exactly the same. 2 to the x, 2 to the x. That part's the same. That's why it's got the same exact shape. It's just the +3 here moves it up. And so it says, how are the y-intercept domain and range affected? So right here, y-intercept just goes up 3 units. The y-intercept goes up 3. The domain is the same, still all real numbers. ARN means all real numbers. So the domain is not affected. Domain's still going to be the same. How is the range affected though? Well, the range of g, the g of x1, is y is greater than 3, okay, because there's our asymptote there. So I'll highlight that asymptote for us here. in yellow. So our asymptote is here on this one. So it's not crossing that one. And it's the x-axis on this one. Those are the asymptotes that we can't cross. So for G, it's greater than 3. That's 3 right there. And for F, it's greater than 0. All right, so that concludes our lesson here on 6.3. And so at this point, I'll say goodbye. Have a great rest of your day, and I'll see you on the next lesson in 6.4.